So our lesson is about finding subatomic particles using the periodic table. Let's review just a little bit though. Remember that all atoms are made of three subatomic particles: protons, neutrons, and electrons. Protons are found in the nucleus of the atom. They have a positive electrical charge and they have a mass of 1 AMU. Neutrons are found in the nucleus also. They have no charge. They're not electrically charged, so they're neutral, but they also have a mass of 1 AMU. So protons and neutrons together give the atom its mass. We'll talk about that more in just a little bit. Electrons are found in energy levels outside of the nucleus. We will discuss that at a later time, but they're outside the nucleus in the electron cloud. Electrons have a charge that is negative, a negative electrical charge. And remember that electrons do not count in the mass of the atom. Electrons are 1,800 times smaller than a proton or a neutron. So that's just like standing on a scale and then picking up an ant and put it on your shoulder. The scale's not going to change. That's the difference in the electrons from the protons and the neutrons. Wrong direction. Here we go. On the periodic table, you're going to see boxes like this, about 110 of them, and each one of them gives us information about each of the elements on the periodic table. The number at the top, this is the atomic number. The atomic number tells us the number of protons. Every element on the periodic table has a unique number of protons. It's like your fingerprint. You have a fingerprint that is different from everyone else's. And so you can be identified by your fingerprints. Well, we can identify elements by their number of protons. Hydrogen, for example, the most abundant element in the universe, has 1 proton. And every hydrogen atom in the universe has 1 proton. That's what makes it hydrogen. Helium has 2. So the number of protons is the identifier for each element. Just below that we have the symbol for the element. This is fluorine, which is a capital F. If an element has a symbol that is 2 letters, the first letter is always capitalized, the second letter is always lowercase, and that is important to write them like that. You will see why when we start dealing with chemical equations. The next number down is the atomic mass. And for most of the elements on the periodic table, the atomic mass is a whole number followed by a decimal. Before we can use that number, we have to round it to the nearest whole number. So fluorine has an atomic mass of 18.998. So we need to round that to the nearest whole number, and that would be 19. The atomic mass is the protons and the neutrons together, because those are the 2 subatomic particles that have mass. They're each 1 AMU. So for fluorine, there are 19 protons and neutrons. So to find the number of neutrons, we simply subtract the atomic number from the atomic mass. And if we did that, 19 minus 9 would give us 10 neutrons. So fluorine has 10 neutrons. And then at the bottom, we simply have the name of the element. Keep going the wrong direction here. All right, here we have a periodic table of the elements. And each one of these boxes represents an element. Again, we have the atomic number, we have the symbol, we have the atomic mass, and we have the name of the element. And most of the periodic tables you use will have a key. So all you got to go do is go back up to the key and you can see what each thing represents on the periodic table. In future lessons, we're going to learn quite a bit more about how to use the periodic table. Finding the number of subatomic particles using the periodic table. Now, I've already talked about this once, but let's talk about it again. The atomic number is the number of protons. And since elements on the periodic table are neutral, they're all neutral, they do not have charges on the periodic table, that means that you're going to have the same number of electrons as you do protons. So if we went back to that fluorine, since fluorine has 9 positive protons, that means that it's going to have 9 negative electrons in order to balance it out and make it a neutral atom. So it's really easy to find the number of electrons. Now, to find the number of neutrons, again, you simply round the atomic mass to the nearest whole number, and then you subtract the atomic number from the atomic mass, and that will give you the number of neutrons. And that's our lesson for today. Hope you understood everything. If you didn't, feel free to ask.